Okay, so thank you very much. Our next speaker is Patrick Heagerty, PhD in 1995, according to my records, and he's now professor and chair of the Department of Biostatistics at the University of Washington, and another institution that produces outstanding students. Kongi, what's your opinion on that? So I've known Patrick for quite a while now, but in prep work here, I looked at his CV a little bit more closely, and I noticed we have a remarkable overlap as far as attending and having business with academic institutions in the United States is concerned. So of course we overlap Johns Hopkins University, the University of Washington, the Fred Hutchinson, and drumroll, we both have a master's degree from SUNY Albany. What's the chance of that? And as Patrick put it this morning, and none of these institutions folded in the process. What's the chance of that? So, Patrick.
All right, super. I just want to say it's really great to be back. It feels like family. Every time I come back, it feels like coming home. It's really super sweet. I've got friends out there. I'll show some pictures of my friends in a minute. And I want to just make clear, really, the main message I want to convey to you is really one of thanks, Chuck. So I think as I thought about the talk, I just wanted to reinforce that primary point. I'm really grateful for everything that's come in my life, really from the experience of being here. So I'm going to try and figure out how to move this forward. All right. So I want to show you that Chuck had a huge impact on my life because he sent me this letter in 1991 that basically said for some reason I would be able to come to this institution despite my less than stellar undergraduate grades at Cornell University. Good school, but I didn't maximize the use of that. So again, I came from upstate New York, super grateful. As I look back, this was a big deal. I think as we get distance, we forget how important this was to me at the time and how important it is to those folks now that we admit. I'll also say that my impression of Chuck at the time was just that he was just super cool. Nothing fazed him. In the letter it said something about scholarship, and it said information about a stipend will be coming later. Just tell you about that later. So I asked him about it, and he's like, yeah, don't worry about it. We'll figure it out. That was basically Chuck's style at the time, and that's what I saw in Chuck. And then this allowed me to have an educational experience here at this institution. And this is a picture of that educational experience here at this institution, where, of course, I'm on the right. I'm see no evil. My colleague, Professor Beth Ann Melton, who's now married, but I still call her Beth Ann Melton, is in the middle, and my colleague Sterling Hilton is on the left. Sterling looks great now. If you look him up on the web, he's a silver fox. He's got all that hair. He's really quite beautiful. So that educational experience led to the second super important thing from Chuck Rohde, which is a letter saying you passed your exams. It's actually quite subtle. It doesn't say you passed. It said you did a good job. You can keep going. It never really said that I passed those exams. And so that allowed me to transition in the 1990s. So that handsome young man on the left is my advisor, Scott Zieger. That handsome young man on the right is the former me. Okay. So this again, I want to thank Chuck for hiring great faculty. I want to thank Scott for putting up with me, really for mentoring me. And I want to say, it was a wonderful experience, super memories. Of course, Scott's amazing. So as a young man, you want to be like Scott, right? That's what you aspire to be. But you've got to be careful what you ask for, right? So there it is. There's basically Scott and Patrick now. My beard's not brown anymore, but that's basically Scott and Patrick now. So I should have been more specific. I want to be successful like Scott. I want to be smart like Scott. All right, I want to really then just transition and say, how did my education really impact my research? And so I want to talk about a couple pieces of research really in the last 10 years. And I want to congratulate Chuck. This hasn't been talked about this morning, but Chuck's recently published a book, which is amazing, a wonderful book, really focusing on the likelihood function. So like Bill, I want to talk about how did that impact me and how does that show up in the work I do now. It's interesting. I feel like I was raised and born a Catholic, and I'm a pretty good Catholic. Academically, I was born and raised as sort of a foundationalist or a foundationalista in the more revolutionary style. I'm not a very good foundationalista, but I'll show you where it does show up in my work subsequent to that. So I really just want to show you a little bit of science, and I'll tell you the stories behind it. And I think, like Bill, it'll show how did that education, how did that influence show up in the work. So here's just a picture, shows a profile likelihood, and that's really what I wanted to say. Part of our training at the time was coursework with a variety of people, but strongly influential from Richard Royal and others, really thinking hard about what are you trying to do and why? What is the evidence in the data? How do you capture the evidence in the data? So I just wanted to share this as a paper I wrote with Scott in 2000, so 15 years ago, where we used that concept to show the evidence in the data. These are just two profile likelihoods for a treatment parameter under different model parameterizations. The story behind this paper is actually quite interesting. I don't know if Scott remembers this, but basically, Hopkins becomes family. And at the time, there were some folks in England that were picking on the family, basically. Multi-level model people. And so we set out to write this paper in part to just push back on those people. We took data from their webpage, in fact. We used their data basically against them. So I think it just speaks to that willingness to sort of compete for what you believe in and that kind of camaraderie of working and competing together. I'll show you a second picture. Again, these are profile likelihood graphs, very much like what Bill showed. This is later work, and I want to just briefly talk about this line of thinking and where it goes and show you that it takes me to some of the work I'm doing today. This is basically a picture. I think the labels are not so great. Again, profile likelihoods trying to show on the left column is basically the likelihood function for the complete data. On the right is a subset of that data. In the middle is a different subset. So it's partitioning the information in the data into two pieces that combine to give the column in the left. And this was for longitudinal binary data, where we started to see there's not much information in the right, which is the people that are all zeros or all ones for a particular coefficient. It does depend on the scenario. But again, the primary point of this paper for us was to bring out a design, think about sampling designs and associated inference, and the likelihood function became a really important part of that work. And again, my training, I think, influenced us to share the information and show the method through its performance using pictures like this. All right. I want to tell you one last little story, which is kind of the current science I'm thinking about. I'll do it mostly in pictures. I'll show you a couple detail slides at the end. But more recently, we've started to think about how do you generalize case control sampling to longitudinal data. So the story I want to show you here is we think about this as being the available data. Maybe on the x-axis is time, on the y-axis is an outcome, and I get to see quantitative information on lots of people. But I don't know their characteristics. Okay? This could be treated people, and I think Scott will talk later. You really want to know what predicts a good outcome, what predicts a good trajectory. You want to link covariates to what you see in that picture. So the question becomes, if you're poor, like the University of Washington, instead of Johns Hopkins University, you have to choose things wisely. Where do you spend your money? Who should you sample here? And your eye kind of tells you that already. Who's interesting, right? Your eye draws you to the people that seem like they're worth learning more about. So our current line of research is really asking that question. How should you take available trajectories, use that information to guide who you might sample? They're all purple still. You can summarize them if you'd like in terms of two parameters, two summary statistics. What's the individual intercept? Are they high or low? What's their slope? What is their rate of change? So collapse that line into summary statistics. They're still purple. I don't know who they are. And then think maybe about partitioning that space and saying, well, I'm going to think of 3 regions. The people that are really interesting are the people with a high slope. They're getting better, let's say. They're really interesting. I'd love to know what are their characteristics. People in the middle are sort of boring. People on the bottom are also interesting. They're getting worse. I'd like to know their characteristics. So this line of work is really thinking about longitudinal data and then outcome-dependent sampling. How should you use that outcome to guide who you sample? This shows the resulting data you might get from a design in this class. You might choose everybody in that top region. I want to get their covariate data. So now I can label those purple people as red or blue, diamonds or triangles. In the middle, I'll get some people maybe, but I'll leave a lot of people still purple, right? I don't need those people. They're not as interesting. And in the bottom, maybe I'll get all those people as well. So it's a biased sampling design. How can we then go back and analyze the data on the original scale? We can, again, use likelihood methods to correct for that ascertainment bias. This is a picture of the truth. This is the underlying structure in that data. And you can see we didn't lose a whole lot by not getting the data on everyone. We were efficient. We were resource smart by only subsampling in that middle region, but getting information on the tails more exhaustively. And then this just shows, again, current work from that paper, or this paper finishes, and I'll show you something subsequent in a minute. You know, I showed you a design in the middle where we sample on slopes, but we may be interested in levels, where we sample on the intercept, or we may be interested in both of them and we sample on a region, so we have low intensity sampling in the center, but high intensity sampling on the outside. And then we see, was that a good idea? What's the relative efficiency of a design that uses that strategy relative to random sampling? So here's a picture. I'll just show you the dots on the right. The dots on the right say for a regression model where there's an intercept, time, group, and group by time, sort of the basic parameters in a longitudinal model. All of the designs, the individual points show variations in specific choices. How intensely do you oversample the edges? Have much better efficiency than a random sample. 150, so as an effective sample size, 1.5 times or 2 times the effective sample. Again, the main vehicle to make this work is the underlying likelihood function with an ascertainment correction for bias. And then, again, just 2 slides to say, in this game, we start to think much harder about all the sources of information in the data. We're throwing a lot of information away. We have the basic stuff that we care about in the outcome distribution, y given x. We've got information in the covariate space, the x distribution, and then we've got constants which characterize a sampling plan, whether I sample someone given just their observed y. We can write down, again, using likelihood thinking, what is the likelihood in that setting? You see y first, you sample based on y, and then you get x's based on people you sample. You can then reorganize it and say the total information in the work so far that I've showed you is just using a piece of that total likelihood function. So actually, quite like Bill, there's parts of it that aren't that informative. In this example, there's parts that we're not using, and now we're asking questions about what is the information in the covariate distribution given your sample. The answer is sometimes absolutely nothing. Other times there is information. It depends on the longitudinal design, it turns out. What's the information in the unsampled people? An interesting question. You don't have the covariate on them. Are they going to tell you anything about the relationship between time and covariates on the outcome? And they do tell you something. I'll show you a picture of that in just a second. So again, the ideas that I think I got from my education 20, 25 years ago, think critically about representing the problem, think critically about the role of the likelihood function helping you understand the sources of information in these data. It's an interesting problem for us as well because, again, you think about the outcome. Q is basically our summary statistic. We collapse the data. We sample based on that. We actually sample coarsely. That's what C is in regions. And then at the end, we basically decide yes or no, you'll get sampled. So in terms of conditioning for this problem, you can think, what are you going to condition on? You can condition coarsely, just on being sampled. You could do it in an intermediate way. What was the region you were from? You could do it too finely, actually. What's the exact value of that statistic that led to your sampling? So I'll just show you this picture as a way of saying we work now, again, with a PhD student in Seattle to again, look at what's the information. Here's a profile likelihood once again. X-axis is the intercept. Y-axis is the group effect. Here's the sampled people. We can recover information. There's the likelihood contours. The unsampled people, you can ask, you don't get to see group, but you get a ridge, basically. They tell you the overall mean, for example. You just can't sort it out into the two group specific means. It gives you information on a line, a ridge. But add the ridge to that sampled surface, and you get concentration of information in the total likelihood. So interesting, unsampled people actually have information that's useful, not strong, but useful for this particular problem. So I really wanted to share that with you, Chuck, that my training, my work, it may not be prominent in my work, but it's there in my entire career, the impact of that education, that impact of that foundational thinking, and I'm super grateful for that. So I really want to close by saying thank you to Chuck Rohde. Thank you for creating an environment which was super fun, really inspirational. I felt like when I was here, I was taught to challenge thinking. Challenge, why do we do it that way? I was really motivated to be creative, think about a better way, think about a different way, and then really modeled by the faculty to have the courage to challenge and be creative and push that forward. So thank you, Chuck.